Chapter 10, Work and Energy, Class 9th CBSE based. Contents, as per Class 9th syllabus. Work done by a force. Energy. Power. Kinetic and potential energy. Law of conservation of energy, excluding commercial unit of energy. Work done by a force, in the same direction of force. Work is done when a force moves an object through a distance in the same direction of force. Unit of work. Unit of work is Newton meter or joule. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, then the work done is 1 joule. 1 joule is equal to 1 Newton times 1 meter. Formula: work, W, is equal to force, F, times displacement, D. Where W is equal to work done, measured in joules, J. F is equal to force applied, in newtons, N. D is equal to displacement of the object, in meters, M. The amount of work done depends on the following factors. I, magnitude of force, greater the force, greater is the amount of work and vice versa. 2. Displacement, greater the displacement, greater is the amount of work and vice versa. Negative, positive and zero work. Work done by a force can be positive, negative or zero. Positive work, when the force acts in the same direction as the displacement. Example, pushing a car forward in the direction it is moving. Condition, angle theta is equal to 0 degree. Formula, work, W, is equal to force, F, times displacement, D, times cos, theta. W is equal to F times D times cos, 0 degree, is equal to F times D times 1 is equal to F times D. Result, positive value for work done. Negative work, when the force acts in the opposite direction to the displacement. Example, friction force acting opposite to the direction of a moving object, like a box sliding and slowing down due to friction. Condition, angle theta is equal to 180 degrees. Formula, work, W, is equal to force, F, times displacement, D, times cos, theta. W is equal to F times D times cos, 180 degrees, is equal to F times D times, minus 1, is equal to minus F times D. Result, negative value for work done, meaning energy is taken from the object. Zero work, when the force is perpendicular to the displacement or when there is no displacement. Example, carrying a heavy bag while walking horizontally, gravity acts vertically downward, but displacement is horizontal, so no work is done by gravity. Condition: angle theta is equal to 90 degree. Formula: work W is equal to force F times displacement D times cos theta. W is equal to F times D times cos 90 degrees is equal to F times D times 0 is equal to 0. Result: 0 work. The moon moves around the earth in circular path. Here force of gravitation acts on the moon at right angles to the direction of motion of the moon. So work done is 0. Work done against gravity. When you lift an object against gravity, you are doing work to raise it to a higher position. This idea is used to calculate the energy needed to move objects upward, such as lifting weights or climbing stairs. So, the formula becomes W is equal to m times g times h, where W is equal to work done in joules, m is equal to mass of the object in kilograms, g is equal to acceleration due to gravity, approximately 9.8 meter per second square. H is equal to vertical height or distance the object is lifted. Numerical example. Suppose you lift a 10 kilograms object to a height of 5 meters. Let's calculate the work done against gravity. Work done, W, is equal to m times g times h is equal to 10 kilograms times 9.8 times 5 is equal to 490 joules, J. The work done against gravity to lift a 10 kilograms object to a height of 5 meters is 490 joules. Energy. Energy is the capacity to do work. It exists in various forms, including kinetic and potential energy. Unit: energy is measured in joules, J, the same as work. Energy is a scalar quantity. Main forms of energy are I. Kinetic energy. 2. Potential energy. 3. Heat energy. 4. Chemical energy. V. Electrical energy. 6. Light energy. 7. Sound energy. 8. Nuclear energy. Mechanical energy. The energy possessed by a body on account of its motion or position is called mechanical energy. Sum of kinetic energy and potential energy of a body is called mechanical energy. Kinetic energy. Kinetic energy is the energy an object has due to its motion. Formula. Kinetic energy is 1/2 of an object's mass multiplied by the square of its velocity, where m is equal to mass of the object in kilograms, kg, v is equal to velocity of the object in meters per second. Example: A ball of mass 2 kilograms is moving with a velocity of 3 meters per second. Calculate its kinetic energy. After solving. Answer: 9 joules, J. Potential energy. Potential energy is the energy stored in an object due to its position or configuration. Formula for gravitational potential energy. Potential energy, P, is equal to m times g times h, where m is equal to mass of the object, kg. G is equal to acceleration due to gravity, 9.8 meters per second squared. H is equal to height above the ground, in meters, m. Example: a stone of mass 5 kilograms is lifted to a height of 10 m. Calculate its potential energy. Potential energy is equal to 5 times 9.8 times 10 is equal to 490 joules, J. Answer: 490 J. Examples: potential energy. Water in a dam. It can turn a turbine to generate electricity due to its high position. Wound-up spring in a toy car. It has potential energy released as it unwinds, making the toy car move. Bent bowstring. The potential energy from its shape change turns into kinetic energy when shooting an arrow. Factors affecting potential energy. Mass. More mass means more potential energy. Height. Higher above the ground means more potential energy. Shape change. More stretching, twisting, or bending means more potential energy. Transformation of energy. Changing one form of energy into another is called energy transformation. Examples: falling stone. A stone high up has potential energy. As it falls, this turns into kinetic energy. By the time it hits the ground, potential energy is zero, and kinetic energy is at its maximum. Hydroelectric power plant. Water's potential energy changes into kinetic energy, then into electrical energy. Thermal power plant. Coal's chemical energy turns into heat energy, then into kinetic and electrical energy. Photosynthesis in plants. Plants convert solar energy into chemical energy in food. Hydroelectric power plant. Energy transformation refers to the process of converting one form of energy into another. For example, in a hydroelectric power plant, water's potential energy is converted into kinetic energy as it flows down, which is then transformed into electrical energy through turbines. Law of conservation of energy. Energy can neither be created nor destroyed, it can only be transformed from one form to another. The total energy in a closed system remains constant. Example: imagine a ball at the top of a hill. At the top, it has maximum potential energy and zero kinetic energy. As it rolls down, its potential energy decreases while its kinetic energy increases. At the bottom, all potential energy has been converted to kinetic energy. Conservation of energy during free fall. A ball with mass mm at height h has potential energy is equal to m times g times h. As the ball falls, its height h decreases, so the potential energy decreases too. At height h, the ball's kinetic energy is zero but increases as it falls. The total of the ball's potential and kinetic energy remains the same throughout the fall. Kinetic energy plus potential energy is equal to constant. Rate of doing work power. Power is the rate at which energy is used. Formula. Unit of power. International System of Units, Watt, W, which equals 1 joule second. 1 watt is equal to 1 joule 1 second. Explanation: power is 1 watt when 1 joule of work is done in 1 second. Average power. Average power is equal to total work done or energy used divided by total time taken. Example: a body does 40 joules of work in 10 seconds. What is its power? To find the power, we can use the formula. Power is equal to work divided by time. Substitute the values into the formula. See the calculation below. So, the power is 4 watts. Power of electrical gadgets. The power indicates the rate at which the gadget consumes electrical energy. Larger unit of power. Kilowatt, kW. 1 kilowatt, kW, is equal to 1000 watts, W, is equal to 1000 joules per second.